right. I got a little drawing for you guys to start off your notes with here. A little sketch of a couple functions to help us with our tricky limits. So we'll have one that's f of x and one that's g of x, and we'll just do a couple of examples from these. Let's see. 2, 3. But I just want you guys to take a look at this example first, and then we'll talk about it. Oops. Sorry, this one's supposed to be down at 2. Okay, so turn to your neighbor. What do you think the answer is to number 1?
So what you do is you basically calculate the limit of x approaches 1 above the graph of x, right? And then do it for the graph, and then you calculate the limit of x approaches 1 x.
Maybe solve both and see if those numbers.
Okay, so what's going on with both of these limits at x equals 1? We have jump discontinuities. Yeah, the limits don't exist. Okay, so if we use our limit laws, does that just mean like dne plus dne equals dne? dne squared, 2 dne? No, that's not how it works. Okay, so the problem that we're running into, right, is we're trying to add these two limits together, but neither one exists. This is one of the keys of our limit laws that we learned a couple weeks ago. The things that need to be true for the limit laws to work, for us to just be able to add the limits, is both limits need to exist at that point. And right now, neither of them do, so we actually can't use limit laws here. What we're going to need to do is do the left and right-hand limits separately for both f and g of x and add them together. So let me write that down for you guys. Hello. Case cast. Can you guys read that? Is that too small? Good. I just want to be able to see the graph at the same time. Okay, so here's basically how this works. We have to do left and right separately. We have to do limit of f of x. We basically break it down. Limit of f of x plus g of x as x approaches 1 from the left. And we see what that equals. And we do limit of f of x plus g of x as x approaches 1 from the right. And then if they equal each other, then the limit exists at that
Why
point.
can't you use limitless here?
Because the limits don't exist at that point. But we can do the left-hand limit separately because they both do have left-hand limits that exist. And they both do have right-hand limits that exist. So we can't do it from both sides combined. So if we look at f of x approaching from the left, what's our limit? 3. And g from the left is 0. So our limit from our left-hand limit is 3. From the right, f of x is what? 1. And then from the right, what is g of x? 2. And so from the left and right side, they both equal 3, which means our limit as we approach from both sides is 3. So you guys give that a try with the second one. We're going to do f times g of x as x approaches -2. Okay. So left and right from both sides are 0. So the limit is 0. Okay, so that's one version of tricky limits. Just breaking it down to left and right separately. Things get a little more tricky when we start to bring in composition of functions. So let's talk about composition of functions. I'm just gonna copy this graph over to my next slide so we can see it. Ugh, spoilers. Whoa, hello? There we go. Okay. Go away. What was it? Please. There we go. Okay. So same graphs. You don't need to redraw them. Turn your neighbor. What do you think this is?
So, g of x be g of 0.
Yeah, I'm deep.
So it's the limit of g is 0, or limit of g of x is g
Yeah.
approaches 0.
I think the whole point here is to do like each calculate each limit separately.
As f approaches -2, which doesn't
Yeah, so those don't include each other.
Yeah. Yeah, so first do g of x, limit of x approaches 0. Yeah, -2, and then you just find f of -2.
But the f of -2 is
Oh,
But for g of x as x approaches 0, it's -2. So then we plug it in here. So then
yeah. I just said
the limit of
oh,
f
limit of
of -2 as x approaches.
Okay. What do we think the answer is? Guesses?
You plug in the equation for the line that crosses around for f of x.
Mhm.
If you take that equation, you take the other equation, g of x, you plug that g of x in f of x. And you get something from that.
What'd you get as the limit?
Actually,
Okay. Okay. Guesses on what the answer is here? Okay, so does the limit, you remember with composition we do the inside first. So if we go to g of x and we approach 0, does that limit exist? Yes. What does that limit equal? Yeah. That's -2. So then the problem is now, as we approach -2 for the outside function, what's the issue? Yeah, that limit doesn't exist, so we have a jump discontinuity. And so the question becomes basically, is it one of these, or is it does not exist because there's a jump? The answer actually is it's one of these, and we have to figure out which one it is. And what we have to look at is, how does g of x approach -2 as x goes to 0? So notice that on g of x here, as we approach 0, the function on both sides is going down towards -2. It's approaching it from above. So as we get closer, it's like 0, -1, -1.5, -2 on both sides. So it's approaching it from a positive direction. So that translates to, when we look at this graph here, we are going to approach the limit of f of x also from the positive direction. And so our limit is -1. Because basically here, it's the same as approaching it. Like we can put a little plus there to say we're approaching it from above, which translates into approaching the limit for f of x from the right.
Isn't it -2?
It is -2. Oh yeah, yes. The graph I have on my paper is at -1, so I put the dot in the wrong place. Whoops. So that's the limit that we want. Because we approach this one from above, we approach this one from the right. So first of all, we start with the inside limit. And just like before, if it doesn't exist, we have to break that up left and right separately. We didn't have to do that for this one because the inside limit did exist. But we have to consider the direction from which the inside limit approaches. Just gonna move this down more. So that's our process.
What if it's just a line?
Like that.
Yeah.
From both sides, then you have to do both sides on the outside. Yep. Yep. So we ended up doing this one for our example. It was approaching the inside limit from above, so that translated to a right-hand limit for the outside function.
Wait, does that first the safest from both directions to both sides or outside?
If the inside function is approaching its limit from both sides, from above and below, you have to do a two-sided limit on the outside. If it translates to left and right, yeah, just combine them.